Okay, so we have an exam on Thursday. Okay, so are there questions on the review? Let me know. $31. Okay. Second. Okay, sorry about that. Okay. So we have 1, 7, 13, and 31. Okay, sounds good. Okay, maybe we'll take these in chronological order. Okay, so it says approximate this by computing the area of each rectangle and adding. Okay, so the area of each rectangle, well, each rectangle has a length of 1 or a width of 1, right? So each of these is a width of 1. Okay, and then we want to do the heights. So this is a height of 3, a height of 4, a height of, what is that looking like, 7 maybe? And a height of 12. Okay, so we have 1 by 2 rectangle, or 1 by 3, sorry, 1 by 3 rectangle, plus a 1 by 4 rectangle, plus a 1 by 7 rectangle, plus a 1 by 12 rectangle. I could actually factor out all the ones, or just the ones, 1 time anything is the anything, right? So the 1 kind of doesn't matter. This is just going to be 3 plus 4 plus 7 plus 12. Okay, and 3 plus 4 is 7, plus 7 is 14, plus 12 is what, 26? Okay, so 26 square units. Okay. Okay, so let's see what else we got here. Okay, number 7, I got 2 7s. People must really want 7. Oh, give the interpretation of the shaded area. Okay, so this would be the marginal profit, right? And the number of units sold. So the marginal profit is like the rate of change, and we want all of the area under the rate of change. So that's total profit. That's all it is, number 7. Okay, it's the total profit. Okay, number 13. Trina says 9. Well, I'll just do 9 for now. Am I showing my work? Yeah. I mean, I could. I mean, marginal profit is p prime of x, right? And we want to integrate p prime of x dx, and that's just going to be from a to b. That's going to be p of b minus p of a, which is total profit. Oh, there's a delay. Oh, okay. Let me stop my sharing. I'll try to share again. Okay, 9. Okay. Okay, number 9. 0 to 3, e to the negative 7. So we want to know what's the integral of e to the negative 7x. That's a chain rule. If I were to take the derivative of this, e to the negative 7x, then I would have to do negative 7 e to the negative 7x. But we're taking the integral, so instead of multiplying by negative 7, right? So if we did a u sub on this, u is equal to negative 7x. Then du would equal negative 7 dx. We divide by negative 7. And so the net result is dividing by negative 7. We'd have to divide by that negative 7, right? So the net result here is that I'm going to get 1 over negative 7 e to the negative 7x evaluated from 0 to 3. Okay, and then we're going to plug in the 3. So this is negative 1/7 e to the negative 7 times 3 minus negative 1/7 times e to the negative 7 times 0. Okay, so this thing goes to 1. This e to the 0 power is 1, right? So this is going to be like plus 1/7. So this is negative 1/7 e to the negative 21 plus 1/7. I could factor out the 1/7, and I would get 1 minus e to the negative 21st power, or 1 over e to the 21. Okay, number 13. Okay, decide whether this is positive, negative, or 0. Okay, well, we have to kind of eyeball this and say, okay, if I put this is going to be positive area, this is going to be positive area, and this is going to be, or sorry, this is going to be negative area, and this is going to be positive area, and this whole big thing is negative area. Well, which is more? Is the negative area more than the positive area? Or is the positive area more than the negative area, or are they equal? So, think of this as negative sand, on the bottom, and positive sand on the top. Which are you going to have more of? Well, I'm going to have more of the negative. So negative. Okay, so area under the curve, under the x-axis operates as a negative value. Okay, well, I'll come back to some of these. This you don't have to worry about. I should have gotten rid of this, but 19 and 20, get rid of. Okay, so you don't have to do 19 and 20. What else we got here? Okay, 31. Yeah, I'm gonna get rid of 30 and 31 as well. And 32. So don't do those. Those are too difficult for this class. And are any of these U sub or no? I can't even read 28. Yeah, just get rid of these. These are too difficult for this class. Sorry about that. I'll update that tonight so it doesn't happen in the next class. Yeah, I can understand why you guys are like, how do you do these? No idea. Yeah, makes sense.
Excuse me, are you leaving 26 in there or also you're getting rid of it? 26 is okay?
Yeah, I think 26 would be okay.
Okay.
Yeah, because you can just do a U sub on that. U is equal to 2 plus 5x. So du is equal to 5 dx, right? So we're going to integrate 10 over u times divide by 5 times du over 5, that's going to give me my dx. So this just becomes 2 over u, which is 2 natural log of u plus c. But what was u? U was my original 2 plus 5x. So 2 times natural log of 2 plus 5x plus c. So yeah, there you go. Okay, let's see about this one. And get rid of 33 as well. Okay, this one, 34, I think we should, well, yeah, we can do that one. That one's just a plain U sub. So let's do 34 and 35. Pretty easy. 34, you can do 35, you want to split up. 35, the trick on 35 is to split this up. Natural log of natural log of x minus 5 minus the natural log of x plus 2. Okay, and so you would do a U sub on that. However, yeah, you just do U sub on this. Then we'd have to integrate, well, u equals x minus 5 for this one. So I would actually break it up into 2 separate integrals. My bad. Must have hit some sort of button. Just trying to see if we went over this in class or not. I don't think we covered. No, we didn't. Yeah, I'm just gonna get rid of this one too. We didn't cover how to take the integral of a natural log, so that one's gone as well. I mean, it's pretty easy, but we didn't cover that formula. Let me do this. Yes, I know. Just like on the derivatives one, let me give you guys a table of integrals, which should help you out a lot. No, I don't want documents. I want not that either. There we go. Don't have that either. That kind of sucks. Okay, let me scan it. I'll make sure you guys have this. So let me scan it and upload it. I'll be right back. Cerritos. 116. Okay. Okay. So we're sitting there. Nope. Didn't want that. Dropbox. F116 reference. There we go. Nope. There we go. Open. Okay. Okay, so I'm uploading this thing called a table of integrals. It should help out a lot. This is so you don't have to memorize what integral goes with what. Okay, so let me share it real quick. Okay. So, go away. Okay, so here's the table of integrals, and you can see that this tells you about the power rule. Okay, so if it's x to the nth equals x to the n plus 1 over n plus 1 plus c. Number 2 is the natural log. Okay. Number 3 is, you don't have to worry about that. That's something called integration by parts. We don't need to worry about that. Number 4 is the e to the x. Number 5 is what happens if you have e to the ax dx. That's 1 over a. Okay, over here, number 8 would have been, well, what happens if I have a natural log of x dx? That's x natural log x minus x plus c. So that tells you that. And then it has this long list of all these complicated ones as well. What happens when you have x to the nth, e to the ax dx, and you just plug in. You just plug in for n and a, and it says, oh, it's just n x to the nth e to the a. So you isolate and say, well, what is n and what is a? And it gives you this value here. Okay, so same thing here, number 6. Okay, but again, it should be a little helpful. If you get, there won't be a natural log on there, but I just wanted you to have this as reference. Okay, especially for these first 8. Okay, so nothing too complicated like this. Okay, yeah. So at least you don't have to memorize, oh yeah, which one, when I have 1 over x, what do I have to do? Well, that's natural log, and stuff like that. Okay. Okay, so going back to the review. Okay. Let's do 34 here real quick. Okay, so u 34, u is equal to natural log of x, right? Natural log of x. Okay, so du equals 1 over x dx. Okay, so let's rewrite this with the u, du. Okay, so the 1 over x dx is actually contained right here. Okay, that's the u sub. Okay, that's my integration factor. And so then I can just, every time I see a natural log, I can just replace it with a u. So this is just 3 minus 2u squared plus 4 times u cubed. And then this is just du, because the 1 over x dx is going to be equal to du. Okay. And so I get, integrate this, it's going to be 3u minus, this is going to go up to 3 and divide by 3. So this is 2u cubed over 3 plus 4u 4 over 4, right? Plus c, gonna have the plus c, always plus c. Okay. But now I have to ask myself, well, what was u? Well, u was the natural log, so I can plug that back in. 3 natural log x minus 2/3 natural log x cubed plus these 4's are going to cancel out, and then I just get natural log x to the 4th power plus c. That's it for that one. Okay. Let's see. This one, 36. Get rid of that one. Get rid of this one. Okay. 39. I could use that table of integrals on 39 as well. What about this one? Can I do anything with this one? Yeah, I can. I could multiply this out, actually, for 38. I could multiply x plus 2 out, x plus 2 squared. If I multiply x plus 2 times x plus 2, I'm going to get x squared plus 4x plus 4, okay? And that's going to be divided by x squared, okay? And so this thing becomes, I could break this up into x squared over x squared plus 4x over x squared plus 4 over x squared, okay? So this thing then becomes, because I should have put it above, I don't know, whatever. This is x squared over x squared plus 4x over x squared plus 4 over x squared, okay, is going to be equal to 1 plus 4 over x plus 4 over x squared. Now I want to integrate this, right? Okay, integrate that with respect to x. Okay, so that's just going to be x. This right here is going to be natural log of x. It's just going to be plus 4 natural log of x. Okay, we could put absolute value bars there. Okay, plus, and this is going to be the integral of 4 to the x to the negative 2. Well, that's going to go up to negative 1 and divide by negative 1. So this is, right, so we have 4x negative 2. And if I integrate that, this goes up to negative 1. If I add 1 to that, that becomes negative 1. And then divide by negative 1. Right, that just makes the whole thing negative. So that's going to be a negative 4x to the negative 1. And x to the negative 1 is just 4 over x. Okay, and then plus c at the end. Okay, so that one we could do. 39, we might be able to use that table to do 39. However, when we take the derivative of 3 to the x power, the derivative ends up being 3 to the x natural log of 3, right? So we could actually just kind of reverse engineer this and just say, hey, you know what? Well, if when I take the derivative, I have to multiply by natural log of 3. What do you think I'm going to do when I have to take the integral? Well, when I take the integral, I would do the opposite, right? And that I would just divide by natural log of 3. So I would get the same thing, but over natural log of 3 plus c for that one. So I would do the antiderivative. What's the derivative? It's 3 to the x natural log 3. And then what's the antiderivative? But again, if I pull up this table, okay, there should be one where it says a to the x. Yeah, right here. So number 11 here. Okay, do you see number 11? Okay. Oh, you can't see it because I haven't shared my screen. Let me share my screen. Okay. So stop. Where's the chat? I need the chat. There we go. Oh, there we go. There's the chat. The heck? There we go. Okay, so, and then if you go down to number 11, okay, it shows that here. Right, so a is just some number to the x is going to be a to the x over natural log of a. And so we just kind of do the antiderivative there. Okay, so this, again, this table of integrals should be helpful for you. Okay. Okay, so I kind of lost track of where we were. Somebody said 29. Nope, we got rid of that. So basically everything after 26, we're good. Paul wants 2, 10, and 11. Let's go back to 2, 10, and 11. Oh, yeah, you can get rid of 17 and 18 too. Okay, 2, 10, and 11. Okay, so 2 is this one. Find the antiderivative of this. Okay, so we have 7x to the 1/2 power, right? So we want to raise that. Well, we could do a u sub on this. Okay, so u is equal to 7x. du is equal to 7 dx. Okay. So divide by 7, and we get du over 7 is equal to dx. So this is going to be the integral of u to the 1/2 times du over 7. Okay. Okay, u to the 1/2, add 1 to that. Well, that's 1 and 1/2, which is 3/2. So this is u to the 3/2 over 3/2 times du, where we integrated. So it's just times 1 over 7. Don't forget this 1/7 on the bottom, plus c. Okay. Well, this 3/2 is going to flip upside down. Okay, and give me 2/3. So this is going to be 2 u to the 3/2 over 3 times 7, which is 21, plus c. But what was u? U was 7x. So this is 2 times 7x to the 3/2 over 21 plus c. That's number 2 there. Okay, number 10. Okay, what is the integral of x to the 1/2? Oh, very similar to what we just did. So x to the 1/2, add 1 to that, that equals 3/2. So this is 2/3 x to the 3/2. Okay, and then evaluate from 0 to a. Okay, and so a is just going to get replaced in there, and 0 as well. So this is 2/3 a to the 3/2 minus 2/3 times 0 to the 3/2. This whole thing is going to go to 0. And so it's just 2/3 a to the 3/2 is my answer there. Okay, number 11. Let's see what we got here for number 11. We have this guy here. I might rewrite it over here. So integral of 0 to 4 g of x, okay, where g of x dx. For less than 3, we're at 3 minus x, right? So we're at 3 minus x if x is less than 3. And we're at x squared for x is greater than 3. Okay, so we have to break this up into two separate integrals, one that goes from 0 to 3 and one that goes from 3 to 4, because we're under two different what I'll say, we are under two different functions. Okay, one between 0 and 3 and the other between 3 and 4. Okay. Yeah, so if you think about what does 3 minus x look like, 3 minus x looks like we're at 3 in the y-intercept, and then we go down to 3. Okay, boom. Okay, so from 0 to 3, we are under this curve here. And then from 3 to 4, we actually jump way up. We jump way up to 9. And then we jump way up to 16. And we're actually under this curve here. This is kind of like what this looks like. So we do have to break it up. Okay. Okay, so 0 to 3, integral 0 to 3 of 3 minus x dx plus 3 to 4 of x squared dx. Okay, so this is going to be 3x minus x squared from 0 to 3 plus x squared is x cubed over 3 from 3 to 4. Okay. So plug in 3. I get 3 times 3 minus 3 squared. Well, that's convenient. That goes to 0. This can't be right. 3. Oh, this is over 2. I forgot the 2. My bad. Like, that can't be right. Okay. Yeah, x squared over 2. Okay. Minus, and then the 0 is going to go in there. So this is 3 times 0 minus 0 squared over 2. Okay, and that whole thing is just going to go to 0. Okay, that goes to 0. Okay, so this is going to be 9 minus 9 halves, okay, which is basically 9 halves. This is 9 halves, okay, or 4 1/2. Okay, so what's this going to be over here? Let's kind of separate this. This is going to be 4 cubed over 3 minus 3 cubed over 3. So that's 64 minus 27 over 3. So what is that? What's 64 minus 27? Is 37. So this is 37 thirds. So this is 9 halves plus 37 thirds. Okay, I don't need the 4 1/2. This is just 9 halves. So this is going to be 27/6 plus 74 sixths, 27 and 74. Is 101 sixths. So and I don't know if that's the correct answer or not. But I could check it, I guess. Number 11. Yep, right there. 1/6. So good deal. Okay. Okay, so we did number 11. It's number 11. Right there. Okay, let's see what else we got here. Okay, that's about it. Okay, any others that you want to see? Let's see. Okay, I'll go over 21. Okay, find the average value of this thing. Okay, so average value means we take this and we divide by the variable. Okay, so the average value, oh no, this is the ice melting theorem, sorry. It's 1 over b minus a times the integral of negative 3t squared plus 5t dt. Okay, and this is from negative 2 to 1, and so this is going to be 1 minus negative 2. Okay, so this becomes 1/3. This is going to be t to the 3 over 3, so that becomes negative 3t cubed over 3 plus 5t squared over 2. Okay, and we're going to evaluate this from negative 1 to 2, or negative 2 to 1. Okay, so what's that going to be equal to? So this is 1/3. Okay, plug in 1. These 3's are going to cancel, by the way. So this is going to be negative 1 cubed plus 5/2 times 1 squared. Okay. Minus, plug in negative 2 now. This is negative 2, the whole thing. Oops. We have a negative of a negative 2 cubed. Keep that in mind. Okay, so this is, it's a negative of a t squared, of a t cubed. So there's a negative there. So don't mess up on the negative. Okay, this negative doesn't go away, just the 3. Okay, so, okay, and then plus 5/2 times negative 2 squared. Okay. Okay, let's clean up these numbers here. This is going to be negative 1 plus 5/2. Okay. Minus, this is going to be negative 2 cubed, which is negative 8. Take a negative of that. A lot of negatives here. Take the negative of that. That's going to be positive 8. Okay, this is going to be 5/2 times negative 2 squared. Negative 2 times negative 2 is 4. 4 divided by 2 is 2. 2 times 5 is 10. So that's 10. Okay, so 5 halves minus 1 is 3 halves. Okay, 5 halves minus 2 halves, right? The 1 is 2 halves. The negative 1 is 2 over 2. Okay, it's 3 halves. Minus 18. Okay, 1/3. I'm going to distribute the 1/3. So this becomes 3 halves times 1/3 minus 18 times 1/3. Okay, so, and then the 3's cancel there, leaving me with 1/2 minus 6. Okay, which is negative 5 and 1/2. All right. Where did I put my master key? Where is this? This is number 21. Yep, this is negative 11 halves, so that checks. Okay, so that's good. Okay, so okay, 12 is just finding the area under the finding the area. Find 2 to 8. Well, there is nothing from 7 to 8. 7 to 8 is nothing. 7 to 8 is 0. So that might be throwing you off there. 7 to 8 is no area. So you just want to find the area under these triangles, basically. And if you can do that geometrically if you want. Okay. You just say that the area of a triangle is 1/2 base times height. We have 2 of them. Okay, the first triangle is going to be 1/2, the base is 5, the height is 5. So this is 25 over 2. Okay, the second triangle base is 2, right? Base is 2 and the height is 3. So this is 6 over 2. Okay, if I add those together, I get 31 over 2. Oh, sorry, we wanted 2. I'm sorry. My bad. This isn't 5 by 5. This is 3 by 3. So this is 2. Like, why isn't it coming out right? Okay, we want to go from 2 to 8. Okay, so 2, not 0 to 8. So this is a 3 by 3, not a 5 by 5. So this is 3 by 3. Okay, so that's a 9 halves. Okay, which comes out to be a 15 halves. Okay. Yeah, which is 7 and 1/2 square units. So that's 12. Okay. 14. 14. Okay, so yeah, let's do this one. 14. U is equal to x minus 4. Du is equal to dx. So this is going to be the integral of 1 over u du, which is natural log of u plus c, which is going to be the natural log of x minus 4 plus c. Boom. Those are ones I like those. That's nice. What about 15? 15 is going to be, this one's kind of interesting, e to the negative 0.7. So this is going to be, okay, u is equal to negative 0.7x. Du is equal to negative 0.7 dx. So I could divide by negative 0.7 if I wanted to. Okay. And so I would get integral of e to the u du over negative 0.7. Okay, so the integral of e to the u is just e to the u. So this is going to be negative 1 over 0.7 e to the u plus c, which was, well, what was u? U was negative 0.7. So this is negative 1 over 0.7 e to the negative 0.7, to the negative 0.7 x plus c. I could leave it like that if I wanted to. I could also clean it up a little bit. And that 0.7 is 7/10. And if I were to divide by 7/10, I would flip that over. So I could rewrite this as negative 10 over 7 e to the negative 0.7 or e to the negative 7/10 x. It doesn't really matter. I just either of these is correct. Okay. Okay, so I guess while we're at it, let's do 16, right? Okay, let's see how we do 16. Okay, 16 again is a u sub. So u is equal to t squared minus 5. So du is equal to 2t dt. Divide by 2. Now we get d over 2 is equal to t dt. Well, there's my t. There's my dt. Right? So I want to go with the integral of u to the 7th power. Okay, du over 2. Okay, so this is just going to be u to the 8 over 8 times 1/2. Don't forget this dividing by 2 there. Times 1/2 plus c. Okay, but what was u? U was this whole thing. Right, so this is going to be 1/16 u, or not u, but t squared minus 5 to the 8th power plus c. Pretty cool. Yeah. And yeah, I'm going to update this tonight. I'm going to get rid of all those that I crossed off. Sorry about that. '16, sorry, yeah. There you go. What is going on with this thing? This thing is possessed. Stop. Yes, correct. Correct, Maximus. They will not be on the test. So do you want me to go back over the ones that are crossed off? Okay, so you can cross off 17, 18, 19, 20, and basically anything after 27 you can cross off. So get rid of everything after 26. I mean, a couple of these you can do by u sub, but you know. Okay. But we've already had practice on U sub as well. So number 4. Number 4. Let's see what we got here. Okay, so this is 3 e to the x. The integral of e to the x is e to the x. So that's going to be 3 e to the x. Okay, 5 over x, that's going to be plus 5 natural log of absolute value of x. 1 over x is natural log. So Paul, I just said that you can cross off 27 through 31. Okay, and then this thing is going to go up 1, right? So 5, 6 plus 1, that's going to be 6, 6. That's going to be 11, 6, right? So that goes up to 11, 6. And so I just multiply by the reciprocal. Multiply by that reciprocal because I'm going to divide by that 11, 6. And this becomes 6 11ths times x to the 11, 6, and then plus c. Okay, always plus c. Always plus c. Okay, so that's number 4 there. Okay, 8. Okay, again, this one we're going to just plug in. This is x squared over 2, 2, plus this is 12, x to the 6 over 6, right? So this actually simplifies. Okay, evaluated to negative 1 to 2. This simplifies to x squared plus 2x to the 6th, evaluated from negative 1 to 2. Okay, plug in the 2, 2 squared plus 2 times 2 to the 6th minus negative 1 squared plus 2 to the negative 1st to the 6th, or 2 times negative 1 to the 6th. Okay, so what is this? This is going to be 4. Zoom in on this. Okay, this is going to be 4 plus 2 to the 7th power, basically. What is that, 128? 2 to the 7th power is 128. Not too shabby. Okay, 128 minus, this is negative 1, that's just 1, plus 2 times 1, which is 2. So 1 plus 2 is 3, so that's 3. So this is going to be 129, I think. All right? Good to know. Yep, that's correct. '21, I already did, Paul. It's right here. Okay, you could review the YouTube, and it'll show you how to do number 21. How many questions are going to be on the exam? I think there's 10, honestly. Let me check that on my other computer here. Okay. And once again, make sure you submit your work. Okay, so exam for questions. Exam for questions. There we go. Sorry, I have to go in as a administrator to see the exam, because it even locks me out if I don't go in a certain way. Because it's like, oh, you can't take this yet. I'm like, thanks for letting me know. Yes, there are 10 exam questions. Okay. There's 2 that are using basic rules of integration. 1 is solving an application. 1 is finding the area under a graph. Two actually finding the area under a graph. Another one is solving a business application. Use the properties of definite integrals to find a definite integral. Okay. And then 3 using substitution. So that's about it. So there are 10. Just make sure that you show all of your work, okay? Because your work will be graded. Yeah, absolutely, Giselle. That works. $23? No, 23 is a perfect one to practice. So it's great. Okay, just all you're doing is integrating, right? And then once you integrate, plug in 150. That's it. That's all you do. Okay, and it shows that your constant is going to be 0, because C of 0 is 0, so your constant is just 0. That's what this thing means here. Where'd my pen go? There it is. So why is it giving you this? So that when you integrate, right? When you integrate this thing, negative 0.16x plus 50, right? You're going to get negative 0.08x squared plus 50x and plus c, and they're going to say, well, this is going to be c of x, which is the total cost function, okay, from 0 to 150, right? This is total cost. And then they're saying, well, what happens when I plug in 0? I get 0, right? So 0, I plug in a 0 here, and a 0 here, and a 0 here, I should get 0. So what does that tell me? That tells me c is equal to 0. So that goes to 0. And so then I just plug in c of 150 into negative 0.08 times 150 squared plus 50 times 150. Okay, and that comes out to some value for the total cost. So I don't know what it is. 150 times 150 times 0.08. 8% of that is 1,800. And then 50 times 150 is 7,500. So plus 1,800 is 9,300. So that's total cost. Screwed that up. How did I screw that up? I messed up somehow. Yeah, let's try that again. Oh, it's not. Wait, no, that's right. Total cost of producing 150 cabinets. So this is plus 50x. This should be divide by 2. That should be negative 0.08. Oh, it's negative. It's negative. That's how I screwed it up. Okay, let's go back. Look at this. I can go back in time. It was a negative. I didn't see the negative. Okay. Boom. There we go. So that, yeah, that's 5,700. Nice. Okay, any others? Yeah, you don't have to do 22. I mean, it's not on the exam, but I mean, it's not too hard. It's just 0 to 0. It's just 0 to 1. I'll just set it up for you. It's 0 to 1. Okay. Or actually, region in the third quadrant. Oh, yeah, that's fine. The third quadrant, because this is going to be, you would have to kind of know what's going on here in the third quadrant. Right, so that's 0, 0, and this would be negative 1, negative 1. And you want the area bounded by those two. So yeah, that's fine. We can get rid of that. Get rid of 22. Okay, 24. Let me take a look at my solution here. Okay, so translator speed. So speed. Okay, speed tells me that we're going to integrate this. Okay, how many words are translated during the 7th to 8th minute? Okay, so we're going to integrate from 7 to 8 on negative 4t squared plus 27t plus 80t, right? Okay, so this is going to be negative 4t cubed over 3 plus 27t squared over 2 plus 80t evaluated from 7 to 8. Okay, so you just plug in these numbers. Let's see what we get here. So negative 4/3, 8 cubed plus 27 halves times 8 squared plus 80 times 8 minus negative 4/3, 7 cubed, 7 cubed plus 27 over 2 times 7 squared plus 80 times 7. Okay, so we're just going to get some, I would just plug that all into a calculator and solve, honestly, myself, but we can clean it up if you want. Let's see, what's 80, what's 8 to the third power? I just clean it up. 8 raised to the third power is 5/112 times negative 4 is negative 2048. It's negative 2048 over 3. Okay. And plus, this is 8 squared, 64 divided by 2 is 32. 32 times 27 is 864 plus 80 times that's 640. Okay. Minus, this is going to be 7 to the third is 343 times 4 is 1372. 372 over 3. That's a negative. Okay, plus 7 squared is 49. 49 times 27. That's 1323 over 2. Plus this is going to be 560. Okay. Okay, so what do we got here? This is negative 2048 over 3. 864 and 640 is 1504. This distribute this negative, and it makes this thing positive, so that's positive 1372 over 3 minus 1323 over 2 plus 560. What is 1323? Oh. Okay, so then we could do 2048 minus 1372. What the heck? Both of them. How did both go on? Oh, I accidentally hit mute. Okay. Okay, and then 248 minus 1372 is 676. Let's combine these guys. Over 2 plus 1504 plus 560 is 2064. Minus 1323 divided by 2 minus 676 divided by 3. Yeah, this is coming out. Why not? Words per minute times t. Well, maybe some of my arithmetic is off. Let me see. Let me make sure that I'm not completely wrong here. Because what I'm getting is 1177.2. So maybe some of this arithmetic is off. Let's check it real quick. The heck? Oh, there it is. Okay, and then we got 4t squared plus 27t plus 80. Let's see what we get here. Yep, it was my arithmetic is off. So you should get 57.167. So obviously my arithmetic is a little off there. So let's see if I can see the error here in my arithmetic. I probably can't, but okay, so the integration is correct. So again, I would probably just plug the whole damn thing into the calculator like this, instead of having to deal with any of those arithmetic errors. So okay. Why am I not screen sharing my screen? There we go. Okay. So come back. Okay, there we go. So 4 negative divided by 3 times 8 raised to the third power plus 27 divided by 2 times 8 squared plus 80 times 8 equals 821.3 forever. Repeated, okay. And then this thing here is going to be 777. Oh, maybe that's where I messed up. No, because that's still 343. No. Okay, so 4 negative divided by 3 times 7 raised to the third plus 27 over 2, 20. What the heck? Plus, oh, that's that much. Shoot. What can I do it for me? Okay, 4 negative divided by 3 times 7 raised to the third plus 27 over 2. I did it again. What the frick? Let's try it again. I can't even use the calculator. This problem wants me to get it wrong. Times 7 raised to the third plus 27 divided by 2 times 7 squared plus 80 times 7. Okay, this is 764.16 repeated. And I just subtract those two numbers. Okay. So I already have that in my calculator. So I'm going to subtract off 821. 0.3 forever is 1/3. So this is, let me go back. So subtract off 821 plus 1/3. That's 821.3 forever equals that. Okay, so this is going to be 57.16 forever. Okay, or 57.2 when rounded. So yeah, it was just my arithmetic that was off. So again, I would just plug the whole thing into a calculator and come out with your answer. Okay, 25 is basically the same thing. Find the total distance from 0 to 4. Okay. 2t squared plus 3t. Hopefully this one's a little easier. Okay, so we have what? 2/3 t cubed plus 3t squared over 2 from 0 to 4. So just plug in 4. 2/3 4 cubed plus 3/2 4 squared. You don't have to really plug in the 0 because that's just going to go to zeros. So you can if you want. If you want to write it all out, you can. Minus 2/3 times 0 cubed plus 3/2 0 squared. But then this whole thing goes to 0. And so then just plug that into a calculator. And I don't know. It's this is going to be 64 times 2, which is 128 over 3. Plus 16 times 3 is 48 over 2. So whatever 128 over 3 plus 24. 66.6 forever. So I would just say 66.7, because if you have another 6 there, it's going to round that to 7. Okay, and then you make sure you have your meters there. Okay, it's in meters. Okay, I think I'm going to call it a day on that one. Okay, I think we went through mostly everything. Okay, on Thursday, I will be in the Success Center. Sure, Alex. I will be in the Success Center from 9 to 1, so keep that in mind.